Okay, today we're going to do our notes number 7, which is simplifying radicals. So we've been talking about exponents lately, and radicals are basically the opposite of an exponent. So inverse operations are the opposite operation. So it's what we use to undo an operation. So if you guys remember, whenever we were doing solving multi-step equations, we had to use inverse operations in order to undo another operation. So with addition, the inverse is subtraction. So this is kind of just a review. For subtraction, it's addition. For multiplication, it's division. For division, it's multiplication. And then we have the opposite of squaring a number is taking the square root. And the opposite of hold on, I think I just did that one wrong. Yeah, squaring a number is taking the square root, and applying an exponent is the radical, which is what we're going to talk today. So the square root and the radical are kind of the same thing. So we're going to talk about what our different parts are. So this symbol around the outside is called our radical symbol. The number on the inside is called our radicand. And the number that is in that little hook part is called the index. And this index is going to be super important come tomorrow. So that is important. So whenever we say square root, we may say the radical. So if there's no index, so if there's not an index, like this one has 3 written right there. If there isn't a 3, then we can assume that the index is 2. The index will never be 1. So if we have to take the square root, it has to at least be 2. So next we're going to go down to our perfect square root numbers. So hopefully you guys kind of know these. A perfect square root means it simplifies completely. So it'll simplify down to a whole number. So whenever we're taking the square root, we think what 2 of the same numbers multiplied together will give you that. So the square root of 1 is 1 because 1 times 1 equals 1. Square root of 4 is 2 because 2 times 2 equals 4. The square root of 9 is 3 because 3 times 3 equals 9. The square root of 16 is 4 because 4 times 4 equals 16. And then you can hopefully kind of see the pattern. The square root of 25 is 5 because 5 times 5 equals 25. Square root of 36 is 6 because 6 times 6 equals 36. Square root of 49 is 7 because 7 times 7 equals 49. Square root of 64 is 8 because 8 times 8 equals 64. Square root of 81 is 9 because 9 times 9 equals 81. Square root of 100 is 10 because 10 times 10. Square root of 121 is 11 because 11 times 11 equals 121. And the square root of 144 is 12. 12 times 12 equals 144. So these are the perfects. These are going to be super important for you to know because not everything will simplify perfectly. So we have to keep that in mind. So that kind of leads us into the next page. Excuse me. It says, what if you have a radical like this, the square root of 20? So the square root of 20 is not a perfect because the square root of 16 is and the square root of 25 is, but not the square root of 16. So how do we simplify this? So radical is simplified if no radicand, so remember the radicand's the number inside, has a perfect square root factor other than 1. And there is no radical in the denominator, which we really won't have to worry about too much. So how are we going to simplify this? It says step 1. Find the largest perfect square or cube root factor. So we got the square root of 20. That's still our example. We have to think, okay, what's a multiple that goes into 20 that is a perfect square? So if we think about it, we know that 4 is a perfect, and 4 times 5 equals 20. We know that the square root of 4 is 2, so that's going to come over to the outside. 5 does not have a perfect, and there's no perfect that goes into it, so we leave it inside the radicand. And that's exactly how we're going to do it each time. So 40, what's a perfect that goes into 40? Hopefully you can think of 4 and 10, and 4 is a perfect. And then if you think about it, 10 does not have a perfect that goes into it. So the square root of 4 is 2, and 10 doesn't have a perfect, so it stays under the radical. Next one, 45. So 45. So think about what goes into 45. You have 7 and 5. No, 7 and 5 is 35. You have 9 and 5. Is 9 a perfect? Yes. So 9 times 5. And then I want you to think, we know 9 is a perfect, but is 5 a perfect? No, 5 doesn't have a perfect, so we are good. So we're going to do 3 square root of 5 because the square root of 9 is 3. Okay, next, square root of 50. The first one you probably think of is 5 and 10, but neither 5 or 10 are perfect square roots, so you're going to have to think bigger. So think, is 4 going to this? No. Does 9? No. Does 16? No. Does 25? Yes. 25 goes into it twice. The square root of 25 is 5, so I'm going to get 5 square root of 2, and I know 2 is not a perfect. Okay, going down to 48. So 48, the first one you may think of is 4 and 12. But 4 is a perfect, but 12 is not completely simplified because 12 there's another perfect in there, which is 4. So we got to think bigger. So another way you can do this is start with the perfect square root below 48. So the perfect square root below 48 would be 36. Can 36 go into this? No. Can 25? No. Can 16? Yes. So this one would be, it's 16 times 3. Square root of 16 is 4, so that comes to the outside. And 3 stays in the radical. Okay, square root of 108. What goes into this? Now this you might have to get your calculator. So do 108 divided by 81 is the next one. That doesn't work. So do 108 divided by 64. That doesn't work. Do 108 divided by 49. That doesn't work. 108 divided by 36. That works. So you may have to get your calculator and just start dividing sometimes, which is perfectly okay. Square root of 36 is 6. Square root of 3. Okay, last one, square root of 12. What goes into it? Well, it's either 6 and 2, which neither of those are perfect, or 4 and 3, and 4 is a perfect. So 4 times 3. Square root of 4 is 2, so you're going to get 2 square root of 3 as your answer. Okay, let me know if you guys have any questions over this. You guys are good to get started on your homework now.